In this video, I'll be talking about Module 11. Module 11 is IPv4 addressing, and this is often one of the most difficult concepts of this course for a lot of networking students. There's a lot of information, and it seems somewhat abstract for a lot of students. So in this section, you're looking at an IPv4 address structure, as well as the different types of IPv4 addresses, including unicast, broadcast, and multicast, how to segment a network, and then you get into subnetting. And subnetting is what tends to be the most difficult for students. But once you learn it, if you learn it well, then you will have that knowledge. You'll have it to be able to understand future subjects in networking as well as for your CCNA exam. So one of the first things that you need to understand about IPv4 addresses is that there is a specific structure. Now, the two parts of an IP address include the network and the host portions. So with the network and the host portions, the network portion is the network number that is assigned, and that tends to be the same, or it's definitely the same, for all the devices on the network. They all belong to the same network. So if you're looking at this example of 192.168.10, then that is the network number, and that is a Class C address. We know that it's a Class C address because the first octet falls within the range of 192 to 223. So that makes it a Class C address. So therefore, the first three numbers would be the network, and the last part would be the host portion of the address. So the host portion can vary. It can be different numbers, but the network portion will be the same. Now, anytime you enter an address, you enter an IPv4 address and a subnet mask. So this is showing you the TCP/IP properties of a PC, and you see the IP address and the subnet mask. Now, anytime you enter an IP address, you'll need to enter the subnet mask, because the subnet mask tells the devices what part of the address is the network portion and what part is the host portion. And the three numbers here, the 255, 255, 255, indicate that those first three octets are the network portion, because the ones in the subnet portion of an address indicate the numbers used. Okay. So they indicate the numbers used, which means that's the network portion of an address. A subnet mask, by definition, is the number of ones used to create the network portion of the address. So it's important to understand that definition, because that will be very helpful in moving forward and to be able to understand your different subnets, especially once you've subnetted your address. So this is showing you those ones if they're drawn out. Now, another way to represent a subnet mask would be the prefix length. So if you're looking at your subnet mask, and let's look at the 255.0.0.0, so this is typically used with a Class A address, and this is the same address written in binary. Well, if you look at the address, that is 8. The prefix length is 8, so that's another way to represent it. So that's why sometimes when you see an address, it'll have a slash notation behind it that's indicating the number of bits used to create the network portion. So if you remember from my definition of a subnet mask, which is the number of ones used to create the network portion of the address, that is written in a dotted decimal form, and the prefix length is literally the number of ones used. So if you count the numbers, so in this case, the subnet mask was 255.0.0.0, That is 8 ones, therefore the prefix length associated with that is a /8. So same thing with the next one, 255.255.0.0, typically used with a Class B network because the structure of a Class B network is network, network, host, host. That is also a /16 because that is 16 ones. Class C is usually indicated by network, 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 host, and that is the 255.255.255.0 written into 24 ones, indicated with a /24. The other addresses are ones that you will actually see with a Class C address. So the first one, well, let's start with this. So this was a /24. This is the default address. So typically you would start with a /24 for a Class C address, and then you may borrow one number. Okay, when you do that, that decreases the number of bits in your host portion. Okay, because it allows you to start segmenting your network, and I'll be talking about that in just a few minutes. But you'll see it move. So see the line move from 1, so you had no ones here, then you have 1, and then you have 2, then you have 3. So that's one thing to remember about subnet mask, is those numbers won't jump around. You won't have alternating 1s and 0s. What you will have is a continuous flow. So you'll go from all 1s to 0s, but it won't ever jump around. Now, one of the concepts that you'll also see in this chapter is the ANDing process. So what is ANDing? ANDing is the process of determining an address. So it's usually used for the network address. For example, if you have a host address that's on 192.168.10.10, and it's given the subnet mask of a default Class C subnet mask, in order to find out what network it belongs to, you can AND those two numbers together. So what's done is that the Class C address, or the IPv4 address of the host, will be written in binary. Then you will do the same thing with the subnet mask and draw a line, and you'll AND the two numbers together. So the ANDing is listed here. These are the rules that you would use. So 1 and 1 equals 1. 0 and 1 equals a 0. So pretty much anything with a 0 would equal a 0. The only time you would have a 1 that would fall through would be if you have two 1s. So if we put these numbers in binary, you start at the left and you move towards the right. So 1 and 1 equals a 1. And the next one, 1 and 1 equals a 1. But in the next, you have 0, 1, so the 0 falls through. 0, 1, 0 falls through. Here you have a 0, a 1, and a 0. And you have that for the remainder of this octet. Over here, same thing, 1, 1, so 1 falls through. 0, 1. So 0 falls through. And if you do that all the way through, then you have this IPv4 address. And if you change that over into binary, then that address is 192.168.10.0. So what that means is that would be the network number that would fall through. Why is that important for you to know that? Well, that's important because that's what a router is going to do with an address to determine what network that a device is on. So it would know how to forward the data. This is often a concept that you will see in your CCNA exam as well. And then one of the other concepts is understanding the different types of addresses. You have network addresses, host addresses, and broadcast addresses. So a network number is a number that has the host portion of your address ending in all zeros, like what we saw earlier. So that is the true definition of a network address. It is when the host address ends in all zeros, the host portion of an address. Broadcast address is when the host portion has all ones. Okay? So the network number is typically the lowest number within the network, so it would be the .0. The broadcast address would be the highest number, which would be typically 255 if you're talking about a default address. So how do you tell if it's a unicast? An easy way to do that is it's a mixture of ones and zeros. So let's look at this scenario here. So there's your network address, 192.168.10.0. See, this is all zeros. Broadcast is 192.168.10.255, which is all ones. And do you see the usable addresses are in between the .1 through the .254? And if this is your host portion, do you see how we have a mixture of the, right here, the mixture of ones and zeros? Okay. So all zeros, network, a mixture of ones and zeros gives you a unicast address. The unicast addresses are used for PCs or host addresses. And then you have the broadcast address that ends in all ones. So if you know where the network lines are in a network, that will help you to understand which parts of addresses are network and which are host. And on the handout that I gave you before with IP basics and hexadecimal numbering, you had this scenario. So this is what you would need to memorize. So this is class A, so the first octet is the network. The next three are host. For class B, you have network, network, host, host. For class C, network, 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 host. So if you can memorize each of these, so for example, the first three networks are the host portion, then you would know, well, I need to look at the structure in the fourth octet for this one. For class B, you would want to look at octets 3 and 4. For class A, the first one would be the network, and the last three would be host. And these are the notes that I provided for you on that. Again, network address is the lowest address in the subnet range. IP addresses that contain all binary zeros in the host portion of the network address. Typically, that's the first number and identifies the whole block. So here's examples for classes A, B, and C. Again, the broadcast address would have all ones in the place of all zeros for the host portion of the address. And then the unicast would be the mixture of ones and zeros. So class D is your multicast address range. That would be looking at the number in the first octet, and that range would be the 224 to 239. So if you're trying to determine if an address is a multicast address, you don't have to do a lot of looking at the network address and the host portion. You would look at the first range. If it's in the range of 224 to 239, it is a multicast address. Okay, this is often a question that you will see within the CCNA exam, where they're asking whether this is a usable number or not. So let's look at another example of ANDing, just to make sure that you have a good understanding of that. I would recommend working through this activity to make sure you have a good understanding. And I want to show you a shortcut with this as well. So let's look at this. So this is the 10, 123, 221, 152. And notice it's 255, 255, 252.0. So this is a class A address, and we know that because the range in the first octet is within that range of a class A, which is up to 127, but they've subnetted out a little bit different. So they've used more of the host portion of the address, therefore it is not the typical Class A subnet mask. It's 255.255.255.0, and that's okay. But what you do is just follow your rules here. And so with this, you will add the numbers through. Remember, a 1 and a 1 equals a 1, but anytime you have a 0, then that equals a 0. So 0 in anything equals 0. So let's look at the first one. So you're looking at the first number, you have a 0 and a 1, a 0 and a 1, 0 and 1, 0 and 1. Then you have a 1 and 1, 0 and 1, a 1 and 1, and a 0. For the next one, you have 0, then you have 1s, a 0, 1, 1. Then you have 1, 1, 0, a 1 and a 1, 1 and a 1, 1 and a 1, 0, 1. And it's okay if it takes you a little bit longer than me. I'm used to doing these, so it's coming a little bit faster, and it will to you the more you do those. But I want to show you a shortcut that'll help in just a moment. But I'll finish out this last one. So 0. So it looks like all zeros. Whoops. 1. So if you flip this number to, or convert it from binary to decimal, what you have is a 10. Then you have, doing your math, so you have the 64, the 32, the 16, the 8, the 2, and the 1. Then you have the 221, and then you have the 0 that falls through. Okay, so here's your shortcut. I want you to notice something. Now, if you don't see this shortcut, it's okay to do the whole thing in binary, but I like shortcuts, and it's very helpful when you're on an exam, whether it be an exam for the class or it's the CCNA exam. Anytime you have all 1s in your subnet mask, the address that falls through will be exactly the same. So do you see how this did not change? You had all 1s, so the 10 falls through. You had all 1s here, so the 123 falls through. You have a mixture over here. Okay, I got this number wrong. Okay, so let's change our number here. So that was 220. Okay, and then you have all zeros over here. So this was a mixture of 1s and 0s. This was all zeros. The all zeros falls through. So this would be the only one that would be different. So technically you could get away with only converting the one that's different. So in that case, that would have been the third octet would be the only one that you would need to do. So, so again, the all 1s would be the same. The zeros, it would be all zeros that fall through. So I would try to do several scenarios with the ANDing to make sure that you have a good understanding. If you want to check it, you can click the check button, and we see that this is correct. Okay. So you can reset it, you can do a new problem, and you can make sure that you have a good understanding of this as you move forward. Now, a few minutes ago, I gave you a little hint on how to determine whether an address is unicast, multicast, or broadcast. Okay. And you have different scenarios. But the easiest way that I think is to look at an address and determine whether it has all zeros, all 1s, or a mixture. If it has a mixture of 1s and 0s in the host portion, it's unicast. Broadcast would be all zeros. And then your multicast addresses, would begin in that range that I was mentioning earlier, 224 to 239. So that's just a quick way of determining what type of address it is. And that is a question that you will see on your exam. So let's look at one scenario in the activity exercise. So you have a destination IP address of 237.192.126.17. Well, if we remember the rules here, you will know that the numbers in the different classes of address are up to 127 for a class A, then 128 to 191 for a class B, and then 192 to 223 for a class C, and then 224 to 239 for the multicast. So looking at the number in the first range here, this would be a multicast address because it's in the 224 to 239 range. So that would be a multicast address. So I would also complete this activity several times to make sure that you have the understanding of your different types of addresses between unicast, multicast, and broadcast addresses. So I hope this video has been helpful in knowing your network and host structure within an IPv4 address, as well as the different types of addresses and the ANDing process. And I've recorded several other videos that should help you as well.